Okay, the recording is started. So, you know, the if else, to make a review, if else and the switch are very similar to each other. They are the control structures. So um, we have a choice like this in the switch. Inside this switch, the choice, and by looking this choice, we are going to the cases. And as I told you before, this choice should be an integer. For example, if this is 1, we are going to case 1. If it is 2, we are going to case 2, case 3, case 4. And we did an example, a basic calculator example. When the user was entering 1, we were checking case 1, which is the addition. When user was entering case 2, subtraction, multiplication, and so on. And also we did an example about this one. You can do the same example. I told you before, you can do everything that you are doing with the switch, also using if else. For example, the same example can be written in this format. We did it before. If choice is equal to 1, do the addition. Else if 2, do the subtraction. Please mute your microphones because I'm hearing some background noise. Oh. And as you know, we did one example also about the grading example. And let me open it as well. Yes, that was the example in the if. So when the grade is greater than 80, A, 70, the letter grade will be B, 60, C, and so on. So that was a very basic example. We are getting the grade from the user. By the way, I'm reviewing very fast. Uh, if you have still questions, you can ask me and stop me. We are getting the grade from the user. If the grade is greater or
So you're too fast.
sorry,
You're too fast.
I know because I am reviewing. We did these examples last week.
Okay.
That's why. But if you have questions, I can gladly answer you. So if the grade is greater or equal to 80, printf A, 70, printf B.
I have a question.
Yes,
For example, 60.5, isn't it we need to put the, instead of int, we'll put float?
yes. For this example, it was integer. You can do this float. If you are
Yeah.
getting float
And
number,
F.
will be change F.
Yeah. And that's it, right?
Exactly. And then now you can
Okay.
put 60.5. You see?
Okay, thank you.
So we did this example. For every level, we are putting some grade. Now, also we did one very simple example. If you remember, pass and fail example, we said if grade, we started from that one last week, grade is 50, if there's just two levels, true, false.
Sir,
Yes,
do you upload the recordings on Moodle or on Teams?
Moodle.
Okay, thank you. Thank you.
All the recordings are on the Moodle. You can review them. I already uploaded all of them today. And if you miss some classes, please review them because you need to catch us.
Okay.
This example also, if grade is greater than 50, printf pass, else printf fail. And you also asked me how we can do the same example using the switch cases. I will do this example now by using the switch cases. That's why I am showing you this one. So how we can do that? Let me open it for you. Again, here we are getting the grade. We have one switch case implementation, and it will give us print, pass, or fail. Let's show you. And what is our case? Grade should be greater or equal to 60. If it is greater than 60, we will print pass on the screen. If it is less than 60, we will print fail on the screen. Like if else. Let me show you the output first. For example, 70. You see 70 is greater than 60, so we print pass on the screen. If we put 40, 40 is less than 60, so we print fail. So how we did it using the switch cases? 1 minute, let me close my window.
Can you scroll down a little bit, please?
Okay, let's continue. So again, we define integer, but as you asked me, we can transform this one to float to have one more general case. If you do this one f, so we can get float numbers. Now, first of all, of course, we are asking the user to enter a grade. We are getting this grade, and using the switch, we are checking this grade to give fail or pass. Let me copy this one and explain you how this is working. No, in the switch, I told you before, it should be an integer value. We are checking this value with the cases, and if they are equal to each other, this means the true condition. And I told you before, even in if you write such as case like this, grade is equal to 60. What does this mean? When grade is greater or equal to 60, this means this one is equal to 1, true condition. Actually, in the inside, it is 1, and if it is 1, we call it true condition. When it is true, we are entering to if. Or if it is, again, grade is greater than equal to 60, and if this is false, sorry, my internet gone. So if this is false, this time what's happening? This grade greater or equal to 60 means 0, which is the false condition. And then if it is false, you are going to the else, in the if else. So how it's happening on the switch? This time we are checking this grade greater or equal to 60. So I wrote you here, if grade is greater or equal to 60, it will be true, which is 1. If grade is less than 60, it will be false, which is 0. So when the condition is true, we are checking case 1, like if else. So true condition is the if, and else condition is case 0. So when this is true,
Sir,
yes.
We didn't make a default case here, right?
Because we don't have a default case here, but you know,
maybe we can imagine that the user has entered wrong number or entered a letter by mistake, so we can return error.
Yes, then you can write here. Yes, you are right. And write here then default the same printf. Let's say a wrong value is entered.
Yes.
And of course, you need to write break. So now it is fine, right? So
Yes,
what's happening? So let's give a numerical example. Let's say the user entered grade is equal to 40. What's happening? 40 is less than 60, so this condition is false. When it is false, and by the way, if you write such a thing as well, if you write grade, like let's define A is equal to grade equal greater or equal to 60, you can write here as well, A. Or in the previous example, that was choice. You can also write choice is equal to grade greater or equal to 60 and write here choice. So what will happen? Whenever this condition is false, choice will be 0. Whenever this condition is true, choice will be 1. So for this case, if the user enter 40, what will happen? 40 is less than 60, so this condition is false. This means choice will be 0. So this will be 0. So how it is working? We are checking this number here 0 with the cases. 0 for 1, it's not equal to 1, so this is false. When it is false, we are going to the next case, which is 0. 0 is equal to 0. The condition is true. The computer is printing on the screen, fail. Is there any question? Or if we enter 80, what will happen? This is choice. What will happen? 80 is greater or equal to 60, which is a true condition. So whenever it is true, choice will be 1. This will be 1. We will check the cases. 1 is equal to 1. This is true. So it will be printed on the screen, pass. And of course, after printing pass, break, why we were using break? To exit from the switch. So we print the pass, there is break command. What break means? This break also, we can use it in the while loop as well. Break means whenever the computer sees the break, exit from this statement. So we are in the switch now, the computer sees the break, exit from the switch. Otherwise, it will be a logical error. So don't forget, when you are using the cases, always put the break. So case 1, it is true, we print the pass, computer sees the break, we will exit the switch and go to the return 0, like here. Any question about that? Okay. So now let's try to implement this example. You also asked me before. Now we have more levels. We will put the letter grades A, B, C, D, and F by checking the grade. Here, as you see, we are checking them one by one with if, else if, then else. How we can do it with the switch? Again, this is the example. By the way, these examples I taught you, they are from the lecture examples. It's already uploaded in the Moodle. This is the example, switch example 2. Again, we are checking that if the grade is greater or equal to 90, put A. If it is between these numbers, put B. If it is between 70 to 79, C, D, and F. So that's why we said if you don't enter these 5 ranges, then default action will be executed, which is the F. So again, we will start the program in the same way. First of all, of course, you can do this one again as float and take the float number. We will enter the grade. We will check the grade. And what's happening here? This is the important case. So let's try to... sorry, this. So I think we can do like that. 1 minute. Okay, so if you want to put, I told you before, inside the switch, it should be integer. If you want to define this one as a float, we are getting the float number, you need to convert it to the integer. And how we are converting it? Like this. If you write int grade, so what's happening? you are getting a float number, and inside the switch, we are converting it to integer again. Or you need to define as integer in the beginning. But if you want to use a float number, if you have some floating points, then inside the switch, you need to convert it to integer. Otherwise, as you see, you will get an error. Like inside the switch, integer should be used. So how this program is working, let's check it out. Let's say we entered grade is equal to 75.5. So what will happen, can anyone answer me, when you write integer grade? This is float and I write integer grade. I told you before what will happen. Anyone?
It will take 75 instead of 75.5.
Exactly. If you take it as integer, this floating point will be removed. So what will happen? You will get it as 75. And then you will divide this number by 10. So what will happen? 75 divided by 10 will be 7.5, right? And again, this is inside switch. So as an output, it will be taken as an integer. So what will happen? This part will be removed as well. Just 7 will be taken. So we will check the cases. Case 7, print C. Let's try. So inside the switch, all the floating points will be removed. And we will check basically 5 conditions. Greater than 90, it's here, I wrote you here. You see, greater than 90, integer between 90 to 99 will be 9. Why is that? Because, for example, 95 over 10 will be 9.5. Inside the switch, this floating point will be removed. So it will be just 9. So we will just check switch 9. You see, case 9, printf A. Or this example for 70, if you write 75.6, because I wrote integer, this part will be removed. It will be just 75 divided by 10. It will be 7.5. After the switch, just an integer value will go out. So this will be removed as well. Basically, we will just take for the floating point, this one. If it is 75, we will just get 7, the first integer. If it is 89, we will just get this 8, the first one. If it is 56, we will just get 5, which is the first one again. So let's do some couple of examples. Let's say grade is equal to 56. So what will happen if grade is equal to 56 divided by 10? It is 5.6. What is 5.6? It is basically 5 because out of the switch, the integer value will go. So you should check case 5. Let's check it one by one. Case 6 is not equal to 5. False. 7 false. 8 false. 9 false. All of them are false. So the default action will be done, which is printf. It is basically like if, else if, then the default action is the else. Or even you can do some other cases for the printf, then put another default value, but this example is working like that. Or if you put 78, again, what will happen? Divided by 10, it is 7.8, but we will just take the integer, which is 7. Case 6, false. Case 7, true. So printf C. Any question?
And if we get 100%, we have to write case 10.
I think yes, for case 10, we need to write another one here. You are right. If you put 100, then we need to have another case. And again, printf.
Sir, can't we like make case equals more than or equal 9, or it doesn't work like that way?
No, you cannot do that. You should write everything inside the switch, then check it by the cases, okay? So from here, an integer value should put as an output, and with this number here, you will check the cases. This is how it is working. But this is an example, but for this example, I think to use if-else-if is more logical than writing this one. Because we did this example before, I think it is easier to implement with if-else. Here, you see, this is, I think, more understandable. Check grade is greater 60, 70, 60, 50, and else. For this specific example, I think if-else is better. But I want to show you that you can do the same example using the switch as well. Is that clear?
Yes, sir.
Okay. So that
Sir,
was the
can I
last.
ask something about the
Yeah.
cases?
Yes, of course.
For the cases, we put integer values. Can we use and or operations to determine the cases, or it should be just in integers?
Just one integer.
Okay.
Otherwise, I think you can use it, but it's not make sense because you might confuse the program. It's if you want to use switch, just give one specific integer inside the switch, okay?
Okay, sir.
Otherwise, it is better to use if-else. If you have, and or blah blah, it's better to use if-else. Even when you are reading the code, it's more understandable when you write it with if-else, okay? Actually, the best example for the switch is this one. You see, you are taking a choice from the user. They are just integers, 1, 2, 3, 4, and checking the cases. And if it is out of this 1, 2, 3, 4, we are executing the default, which is wrong choice is entered. For the rest, I think usage of if is better than switch. And I prefer to use if. Okay, let's continue. Now the control structures are finished. Maybe we will do some more examples later on. But we will now start the repetition statement and try to explain what is the difference between repetition statements and the control statements that we covered before. As you can understand from the name, it's repetition. So these conditions are repeating themselves. Repetition structure, programmer specifies an action to be repeated while some conditions remains true. So this is the main difference. In the if, how was it? If you say if a is equal to, let's say 70. So when this condition was true, we are doing some action here. When it is false, you are doing some other action in the else. But it was just one shot. You were not repeating anything. You were just checking once. If the condition is true, execute the statement. If it is false, execute another statement. Like it was like in the flow chart, like that. You have one start, you are checking the condition. If it is true, print pass, go to the end. If it is false, print fail, and again, go to the end. But in the while, until the false condition came, we will keep repeat the same action. Let me, also I will show you the flow chart and I think you will get it better. Where is it? Okay. So this is an example. While there are more items on my shopping list, that's why we are using the while. So while the condition is true, the loop will continue. Purchase next item and cross it of my list. For example, when you go to shopping, how we are doing it, if you have a shopping list, whenever you buy the item, you are crossing it and going to the next item until you finish all the items. So you can think it like that. Or for example, we did a grading example. What we did one grade, 80, check the condition and give A. But what if I have 100 students? What I'm going to do, I will copy the same code 100 times. Of course, it's not make sense and it's not practical. So to do that, to do same operation repeatedly, we are using loops or repetition statements. While is one example for that. Also, next chapter we will use for loops. And you can do everything like if and switch. You can do everything you are doing with while, also using for loop in a different syntax. As you see, while loop repeated until condition becomes false. So for example, if you have 100 students, this you will take the grades from the user until the last student, until we reach the 100th student. When we reach the 100th student, the while loop will be finished. And this is how the flowchart looks like. So here is the start. We have a condition. Let's say product is less or equal to 100. If this condition is true, you see we are going back to the start. So we are starting from top, checking the condition. Whenever it's true, we are going again to the top. Checking the condition. If it is true, we are going to top again. But how was in the if? You are checking the condition, true or false, doesn't matter. You are going to the end. You will not go back to the start. But in the while, that's why we are calling it a loop. When it is true, we are going back inside a loop. You see, if it is true, do the action, check the condition again, here. If it is true again do the action, go back to the start. Check condition. So every time we are checking the condition, if it is true, we are starting the loop again. Checking condition, go back. When the false condition came, the while loop will end. So until the false condition, the loop will keep going. Let's do this example here and try to understand how the loop is working. So you need to keep in your mind that while loop will work until this product is greater than 1,000. When it is greater than 1,000, it will be false, the inside will be false, and we will exit from the while loop. Let's do this example and try to...
Sorry, sir. What does this code mean? How can we use this code?
What you mean?
What
here.
Yes, what are we? What
Yes,
happens?
you will see now. I will give you the...
What's the uses of this code?
Yes, the uses. Yes, the use.
About this one.
Yes.
Okay, you will understand. When I do it like... So let me copy it. When I give you the output, you will understand what's happening. Okay? Again, while is like if it is just one statement like this, you don't need to open braces. But if it is more than one statement, you need to open the braces. So if you want to write a printf here, like the if, for example, if you want to write printf, product equal, let's say it's an integer. So you need to open the braces. So what will happen here? Let's try to examine it. So we define an initial value, which is product is equal to 2. So first of all, in the while loop, you need to check the condition. What I told you, if the condition is true, you will enter the loop, do the iteration. If it is false, you will exit. You will finish the loop. You will terminate, or we say it the termination point. So whenever the false condition comes, this means terminate the while loop, exit from the while loop. Like we did in the switch. What we did, we write there break. So break means exit from the switch. Go to the next action. So here, when the false condition came, the while loop will be over. So we will continue from here if there is another action. So and every time when you enter a loop and do an action, we call it an iteration. So we will first start from here. Product is equal to 2. We check the condition. We will tell this one first iteration. Then when you enter again the while, you will go to the second iteration, third iteration, until we reach a false condition, which is the termination point. So let's try to do it. So in the first iteration, what will happen? Product is equal to 2. We checked if product is less or equal to 1000. It is, right? Product is less or equal to 1000, so the condition is true. When the condition is true, do the action inside the while. So this is true. So what we will do, product, I told you that do the action on the right and assign it to the left. So what is the initial value for the product? It is 2. So now product is 2 multiplied by 2. We update the product value to 4. What will be the output? If I am printing every iteration on the screen, and let's say m. On the screen, we are going to see product is equal to 4. Now you update the value, the product value to 4. So what will happen? Like this one here. The condition is true, you see. This condition is true. We update the product value. We will go back and check it again inside the while. So we will go back to the while. Product is less or equal to 1000 here. We check it again. If it is true, keep repeating the same action. That's why it's a loop. So now we update the product value. Now new product value is 4. This is 4. We check again our condition. It is less or equal to 1000. The condition is true. We will do the same action. We will enter again the while loop. Here, this is now 4, okay? We will go to the second iteration. We will check here if 4 is less or equal to 1000. The condition is true. So what will happen when the condition is true? Do the action inside the while. So product is equal to 2 times product. What is the initial value for the product? It is 4. So 2 times 4. We will update the product value by 8. Any question up to now? In the output, what we will see, product is equal to 8. Again, we have 8. What we are going to do, we finish the actions inside the loop. We will go back again to the start, check the condition. 8 is less or equal to 1000. It is true. Again, we will enter to the while loop and do this action. What is the action? Product is equal to 2 times the initial value of the product, which is 8 from the last iteration. So we will see product is equal to 16. So when we print on the screen, product is equal to 16. So what do you think this program is doing? Any idea?
It's just multiplying by 2.
So this is 2 to power 2, right? This is 2 to power 3. This is 2 to power 4. So basically, we are taking 2 to power n up to.
It's look like give a series.
Exactly. That's while loop or loops are mostly the series. For example, this 2 to power n, any kind of series. What else? We have an example. I forgot the name. What we say to this one, for example, like this, I forgot the name.
Factorial.
Factory.
Factorial, yes, sorry. So if you want to do factorial, also you can use while loop like this. Start from 5, decrease it one by one until reaching 1. For example, if you want to do 5 factorial. Also, we will see the example about it. You got the idea, right? This will be your initial condition. You will decrease it one by one until you reach less than 1. When you reach less than 1, the program will terminate. Or here, what is our condition? So after this one, what will happen? Product will be 32. Then 64. 128. 512. So now, which 1, 2, 3, 4, 5, 6, 7?
You missed 256.
Sorry, yes. 256, 512. So 1, 2, 3, 4, 5, 6, 7, 8. At the 8th iteration, product is now updated as 256 times 2, which is 512. So what will happen after this one? Again, it is 512. We check the condition. It is still less than 1000. We will multiply it again, right? So product 512 times 2, which is 1024. So now here we print it again on the screen. Product, because we are still in the while loop, 1024. After that happen, 1024 is not less than 1000. So the while loop will end because we come to the false condition. Now this is false, so we will exit from the while. The while loop will end, like here. You see, the true condition, we do the loop until we reach this termination point. We do this loop. When we reach the termination point, whenever this condition is false, we will exit from the while loop, and the while loop will end. Any question? So we update this product value in each iteration and check it by the condition. When we reach the false condition, in this case, it is 1024. We reach the false condition, we exit from the loop. Let's check it. This is the example. This is the same example, you see. For 816 up to 1024. At the 1024, this is the false condition. So we exit from the loop and the program ends. Because there is no other action, we come to the return 0. The program will end. Any question? I hope you got you understand the difference between simple if and the while. In the if, it is just one shot. You are checking the condition, doing the action one time. In the while, you are keep repeating the same loop until you reach a termination point. In this case, it is 1000. Okay. Sorry. Not providing the body of a while an action that eventually causes the condition in the while to become false. Normally, such a repetition structure will never terminate. An error called an infinite loop. So what does this mean? imagine you have a while loop, but you don't have a false condition. So every time it is true. What will happen? The program will never exit from the while loop. The program will stuck on the while loop. That's what we call infinite loop, because the program will never terminate. It will be just stuck on an infinite loop. Keep repeating, because like here, you will not have a false condition. What will happen? You will just repeat the while loop inside an infinite loop like this, because you will never have a false condition. For example, if you say product is greater than 0, what will happen? This condition will be always true, right? Because you start from 2, you enter the while loop, you just increase it 2 by 2, 2 to power n. So it will be always greater than 0. So let's run this code and see what will happen. Of course, this is, I think, the last thing that the program can see to you, to show to you. Wait 1 minute. A product is equal to +1. You see, there is no termination point. We are just going to infinity. You got the idea, I guess. Like, you need to select a good termination point that your program will terminate. For example, if you select such a termination point, your result will be always greater than 0. So your while loop will be never false. If it is never false, then you cannot exit from the while loop. Your program will stuck inside an infinite loop. Spelling the keyword while with an uppercase W as in while, remember that C is a case-sensitive language. All of C's reserved keywords such as while, if, and else contain only lowercase letters. You asked me before this one. You cannot write a code using an uppercase letter like this, while. Or you cannot write if like that. They should be all lowercase. Okay, we did this example. Let me show you this again. I am doing an example from the lecture examples. So I define a counter. I initialize the value from 0. I set counter is equal to 1. We have a while loop. In each iteration, we will increase the counter 1 by 1, print it on the screen, and see what's happening inside. What is this program doing? We set int counter is equal to 1. So here I will show you the iterations, and here I will show you the output on the screen. Of course, if you don't write this printf, if you remove it, you will not see on the screen. But inside the loop, these iterations will be done. But to see them, like each iteration, you can put here a printf and observe what's happening in each iteration inside the while. So in the first iteration, what will happen? Counter is equal to 1. We check the condition, always check the condition, and if it is true, do the action. And to do that, of course, you need to have an initial value, because you need to give a program a start. So for this case, it is 1. Also, you can start from 0. But my program is starting from 1. So counter is equal to 1. For this case, counter is equal to 1. We check the condition. It is true. So let's start from 0. So we will have blah, blah. The initial condition is counter is equal to 0. We check the condition. It is less than 20. We increase the counter by 1. How this is working again? Do the right-hand side action, which is counter plus 1. This is the previous value. Increase it by 1. Assign it to the counter. So update the counter in each iteration. Increase the counter by 1 in each iteration. So it is counter plus 1. This counter, the previous value is 0. 0 plus 1, it is 1. So now we will print it on the screen. Counter is equal to 1. Then /n means go to the new line. Now the new counter is 1. We are checking the condition. It is still less than 20. So we will enter to the while. 1 is less than 20. We enter to the while. Counter is equal to counter plus 1. Counter. So in this right hand, put the previous value and assign it to your new value. So counter is my previous value, which is 1. 1 plus 1 is equal to 2. So on the screen, you will see counter is equal to 2. Then /n, go to the new line. Now my new counter is 2. Again, we come back to the start here. We check the condition. Counter is less than 20 still. So we will enter to the while loop. 2 is less than 20. We will say counter is equal to counter plus 1. Sorry, my internet gone. So the previous value is 2. 2 plus 1 is equal to 3. So this will goes up to 20th iteration. What will happen? Counter will be equal to the previous result will be printed 19. Then counter is equal to 19 plus 1, which is 20. We will print it on the screen. After that, what will happen? 20 is still greater or equal to 20. So it is true. We will increase counter by 1. Counter is equal to 20 plus 1, which is 21. Now this is the false condition. We will exit from the loop. And we will increase it to 1. The false condition came. We are going to exit from the loop. Of course, we start this one from 0. So basically what we are doing, we are counting the numbers from 1 to 21. How I can change this code to make it 1 to 20?
Delete the equal sign.
Exactly. If you delete this one, what will happen? When you reach the 20, this will be the false condition because it should be less than 20. So you will not go to the next iteration. Here it will be false. The loop will finish. You will exit from here. Let's run like this. You see, we are counting 1 to 20 because when the counter reaches 20, it is not less than 20, it is equal to 20. This is a false condition. We will finish the while loop. Is there any question?
So, sir, there's no difference between this and the previous example, just the name, counter, and product.
Yes, in the previous example, we were always multiplying by 2, right? Here, we are increasing it by 1. This is the difference. Just the action is different. But of course, the logic behind it is the same. You are doing some action, and checking it with the condition. It's always like this. First check the condition. If it is true, do the action. Again, when you update the value, check the condition, do the action, like this, inside the loop. And they are good examples to understand how to update these values. You see, here we are increasing it one by one and updating this counter value. In the previous example, it was like this, 2 times product. This time we were multiplying the product, the initial value of the product, by 2 and updating this new product value, okay? So,
Okay, sir.
For the previous example,
yes,
if we don't want to print 1024, how can we do that?
and then you will select your, but you can select like this. Oh, sorry. Like that. Yes, okay. Just you need to change this termination point. Clear?
Okay, hocam. I asked it before. In the condition we put that it should be less than 1000. That's why I am asking how can we exclude the last point.
Okay, if you decrease it to 5, because you know the last one is 512. After that you are multiplying it by 2 to 1024. If you want to exclude the last one, you need to reduce your gap. You need to reduce the termination point to the 512. Is that clear? You see 1024 is gone because this is now my last iteration.
Yes, hocam.
Okay?
Okay.
Okay, in here, how I can do this example to print the even numbers from 0 to 20. Any idea what I'm going to change in this code?
What's the question?
Now I print all the values from 1 to 20, right? But I just want to print the even numbers from 0 to 20.
You define, I think you define counter as 2, and then
we can
plus
add
2.
2. Yes, we add 2.
And
We will
counter
use
is equal
the
to 2.
remainders.
Counter is equal to 2. Counter is equal to 2.
But if you do this 2,
then
you will start from 4. I don't want to do that, right?
Oh, okay, okay.
So we will use remainders. If result is 1, we will add plus
Okay,
1 or something like that.
I will also show it to you. Okay, this is now even numbers, but how I can include the 0 value as well? I want to print also the 0 value. How I can do that?
Minus 2?
No.
No.
It is very simple.
We can make print
before,
before the adding.
For the counter.
Exactly. If you move this one, sorry, if
you move the printf
before the counter, now you will first print the 0, then increase it by 2. But of course, if you want to include 20, what you are going to do? Put the equal sign.
But listen, don't put the equal sign, it also adds the 20. Remove the equal.
Okay, but I want to include the 20 as well. 0 to 20, even numbers.
No. Even if you remove the equal, it adds the 20.
It will be not, because I am printing it before the counter. You see? Because you are increasing it, but not printing it. You are here. What's happening? When you come to the 20, so let's say this is 20, 18, then you are increasing it and exiting from the loop before printing the value. You got the idea? It's different than the previous examples because here we were printing it after the counter. So that's why we were printing the last value of the counter. But now in my example here, we are printing the value before the counter increment. So what will happen? When this counter reaches to 20 here, sorry, reach to 18. We check that the condition is true. We print it on the screen.
Sir, we can't hear you.
Can you hear me now?
Yes, sir.
Yes, sir.
Yes, sir.
You got the idea here, right? First we are printing, then increasing it. That's why the computer is not printing to any value. Because you
Yeah,
increase it, termination point came, so you will not enter again while loop to print 20. But if you put it here, if you move to here, what will happen? First you will increase it, print it on the screen, then go to the termination point. This is the difference. So
Yeah.
you need to be careful when you are about the orders inside the loop.
Your mic again, it's muted.
I think someone is muting me. Please don't do that.
Yeah.
We are losing time for that. Okay, so if I want to print the odd values, what should we do?
+1? No.
Think about it. Think about our initial condition.
Counter equal 1.
Exactly. If you start from 0, it will be, if the increment is 2, 0, 2, 4, 6, and so on. If you start this one from 1, this time it will be odd numbers, 1, 3, 5, and so on.
Yeah.
You see? Odd numbers from 1 to 19. Okay, I think it's enough for this example. Let's move on. Counter control reputation. Actually, this was an example about counter control reputation. So we have a counter, we have a termination point. For this example, it was 20. When the counter reached 20, or of course for this example it is less than 20. When the counter reached greater than 20, we were terminating the while loop. So this is what we call counter controlled while loop. We have a counter value here. We are checking it and increasing in every iteration. It's up to you, the increment. It will be 1, 2, or whatever. So you always have a 1 counter and checking the termination point. This is what we call counter controlled reputation. So loop repeated until counter reach a certain value. Like in our example, it was 20. Definite repetition, number of repetitions is known. Of course, we know the repetition. If you say 20, there are 20 repetitions. Example, a class of 10 students took a quiz. The grades integer in the range 0 to 100. For this quiz are available to you. Determine the class average on the quiz. So now we have another example. We have 10 students, or imagine our class, we have 55 students. And I will do you a quiz, grade you, and after grading you, I want to write a program to calculate the average of the class. For this example, we have 10 students. Of course, the grades range from 0 to 100, and we are going to we will write a program to calculate the average of the quiz. So here it is. Let's do this one 5 to show you an example, a sample, how this code is working. So we will enter now if the students are 5. we will enter 5 grades. Let's say 56, 98, 65, 74, 32. The program will add all these grades. It is 5, so we will add these 5 grades and divide it by 5. Oh, sorry, this will be 5. I am doing it 5 to avoid entering 10 grades, to be faster. But the real example is for 10 students. So we have 5 grades, we add them up, divide it by 5, and the average of the class is calculated. Of course, for this example, they are all defined as integers, so we are calculating the average of the class in integer. But you know how to convert it to float. You can define all of them as float, also calculate average in a float number. So let's check the example here. Let's check what's happening here. So first of all, what we need to do, we need to add the numbers. We need to sum all the grades and then divide it by 5. And don't forget, when you are using a loop or any kind of addition, multiplication operation, you need to first initialize them. For example, we are using this total to sum all the grades and save it inside the total. That's why, first of all, we are initializing the total value as 0. Because this is our initial value, 0, then we will add all the grades. And for the counter, we initialize as 1. If you want to initialize as 0, then you need to remove this equal sign. So you will 0, 1, 2, 3, 4, 5 students. But if you are making it 1 for 5 students, you want to make it 5. Because 1, 2, 3, 4, and 5. 5 will be our last iteration. Okay, let's do this example. Okay, first of all, total is initialized as 0, counter is initialized as 1. In the first iteration, what will happen? We check if counter is less or equal to 5. This is for 5 times, so loop will be loop 5 times. Counter is 1. This condition is true. 1 is less or equal to 5. We will enter to the while loop. So on the screen, what we are going to see, enter grade, and we will take the grade using scanner, like here. To see, enter a grade. We enter 50, then we will enter the next grade, up to 5 students. Let's say the user entered grade is equal to 50, like I did. Then what we are going to do, total is equal to total plus grade, like we did in the previous examples. It was counter is equal to counter plus 1. So put the initial value, add the grade, and update your total value. The initial values will be in the right hand side. What is the initial value for total? It is 0 for the first iteration, plus grade. We took it from the user as 50. So now the total is updated as 50. After that, increase the counter by 1. Counter, it was 1. 1 plus 1, it will be 2. Now counter is 2. We will check the condition. So after finishing each iteration, first check the condition. Now new counter is 2. We check the counter. 2 is still less than 5. So the condition is true. Again, we will enter to the next iteration. So on the second iteration, again, we ask the user the grade value. Let's say the user enters 65. This time what will happen? Total is equal to the right hand side total is the previous value. What is the previous value stored in total? It is 50 plus the grade. The grade is entered as 65. So basically, as you see, we add these two numbers, 50 plus 65, which is 115. Then increase the counter by 1. So counter, the initial value was 2, 2 plus 1, which is 3. Again, we finish the while loop. We will check the condition. 3 is still less than 5, so this condition is true. We will go to the next iteration, the third iteration. On the screen, printf enter grade. The user will enter the grade, let's say 95. So total is equal to total plus grade. This is the previous value. What is the previous value? It is 115 plus 95. So it will be 200 and then after the total, we will increase the counter by 1. Counter will be, the initial value is 3. 3 plus 1 will be 4. Four is still less than 5. We will go to the next iteration. Let's say let's continue from here. Let's say user entered 43. Total, now we are here. Total is equal to total plus grade. The initial total value is 210. 210 plus 43, which is 253. After that, increase the counter by 1. Counter is equal to the initial value of the counter, which is 4. 4 plus 1 is 5. So 5 is still equal to 5. So this condition is true. If it was like that, the loop will finish because it is less than 5. But in our condition, it is less or equal to 5. So it also includes the counter is equal to 5. So counter is equal to 5. This condition is true. We will go to the next iteration. Let's say the user entered grade with the scanf. Grade is equal to 60. Total is equal to the previous value of the total, which is 253 plus 60 which is 313. After that, increase the counter by 1. Counter is equal to 5 plus 1, which is 6. So what will happen here? The counter is updated as 6. 6 is not less than 5. So this is our termination point. This condition will be false. The while loop will end. Now what is my last total value after the while loop? Total is equal to 313 because while loop now ends. So we save this total value as 313. This loop will end. We will do this operation here. Average is equal to total over 5, which is 213 over 5.
$62. 62.
62.
Yeah.
Okay, because you just take the integer value, right?
Yes.
It was 62 point something, but because we saved, it was 60.6, but we saved our average as integer, so this floating point will be removed, so it will be saved as 62. Is there any question? So I try to do it like very slowly, and if you want to understand these loops, you should do like me. You will start from here, check the first condition, and do these actions for each iteration. For this case, it was actually a very simple example. We are adding the numbers, we are updating this total value, also the counter. Why we are using the counter? To check the number of students. This counter we are using to check the number of students. We want to just take 5 students. And total, why we are using it? To add all the grades to calculate the average. Is that clear? Okay.
Yes.
Let's do the next example. Let me check from here. Okay, we did this one. As you see, while grade counter is less than or equal to 10, I did it for 5, but you can do it for 10, 20, whatever you want. Input the next grade. With printf, we ask the user, scanf, we got the grade. Add the grade into the total. We add the grades into the total. Add 1 to the grade counter. Why we are adding 1 to the counter? To check the number of students. See the class average to the total divided by 10. Print the class average. That's what we are doing. And this is the whole code. So we define a counter, the grade that we are taking from the user, the total value that we are summing the grades, and the average total divided by the number of the students. The total, don't forget, the initialization is very important. If you are adding some numbers, multiplying it, or doing some other operations, first you need to initialize them. For this case, it is summation, so we initialize them as 0, because our first point is 0. Then initialize the counter. It's up to you. If you initialize as 1, make this one less or equal to 10, because we need to have 10 iterations for 10 students. But if you are initializing this 0, then remove this equal sign, so 0 to 9. Again, 10 iterations. It doesn't matter. So loop 10 times. I already explained you here. We add all the numbers and then calculate the class average. And this is an example for these inputs. If a counter or total is not initialized, I am telling you that keep in your mind, always initialize your values. If a counter or total is not initialized, the results of your program will probably be incorrect. This is an example of logic error, because C will not know your initial point. If the computer does not know your initial point, will create some random numbers. That's why always initialize your values. So initialize all counters and totals. Let me check this. What is this example? Okay, so now what we did, we know the number of students, which is 10. So directly we write the code with 10. We said counter is less or equal to 10. How we can do it if we don't know the number of students? Any idea? For example, if I don't know this number of students, 10. How I can do this code? If I don't know this number.
Maybe we can modify something in scanf. So if I entered grade like 999, it stopped the program immediately.
Okay, this
No,
is
I think not
yes.
grade. I think total. Total is equal to Yeah, or grade. Yeah, صح.
Yes, great for, yes, this is a good idea. We will do it as well. So we can put, we call it a sentinel value or a termination point, as you said. But be careful. Put, for example, what we can do as a termination point, that it's out of our range, it should be out of 0 to 100, right? What is the best guess for it to put a termination grade? When we enter this grade, the while loop will end. A negative value, right? If you put a negative value, this cannot be a grade. Grade should be a positive value, 0 to 100. So if we put a negative value, let's say -1, when the user enters -1, the while loop will finish. Until this point, the loop will work. This is fine, right? So we are going to modify this one here. Of course, we will ask to the user again. Grade is not equal to -1. So what will happen when the user entered -1, this condition will be false, right? Okay, any idea, another idea? This is one idea.
Maybe you can.
So can I get
maybe
the
we
question
can
again?
we can add another condition, like at the end of every loop, a question say if there is another student, add a number, or if the scanf is equal to void, we stop
Okay, yes, this is same as the previous one. Put a sentinel value to move on or to stop it. This is the same idea. So another idea, this is what I am asking to you, your friend asked to me. What if I don't know the number of students? Here, I know the number of students. It is 5, 10, 20. I am entering it directly to the loop. But what if the user does not know, or I am writing a code, a global code, that we don't know the number of students? The user will enter the number of students. How I can do that?
like if the grade was void.
You can you cannot do it as a loop. I think you can do it as a scanf for the number of students at the beginning, for example.
Exactly. This is another, like, two things. First, we can put a termination point like -1, press -1, stop the code.
Before you initialize this, you will initialize the number of students. Like for example, write printf number of students, and then scanf %d and comma counter, call it as counter, and then it will put the value of counter.
Exactly. So first we will ask to the user how many students you have. So we will say before the loop, before the while loop, we will say printf enter the number of students. It's an integer value. Let's say we define n as a number of students. You need to
and
define.
then remove the 20 and put n.
Exactly. And if you put here n
and n or just n?
Just n, because it's just an integer
because
value.
It's saving it as n.
Exactly.
Teacher.
And n is the address of n. For this is just for scanner.
Okay.
Yes.
Teacher, if we put inside while instead of counter, not counter, we make grades equals, we want to assign empty value.
Yes, here, look, in here, I do this example. You see, for example, I said, while I will show it in after this.
No,
one,
instead of -1, it's just empty value. So if I press if I pressed enter twice or once without entering anything, it just end the loop.
For that, I am not sure, but maybe instead of that, you can put a character.
Okay.
This is not better instead of printing, because when you print enter, I think this scanf will get it. Will not get empty values. They are
Ah.
not okay. That's
Okay.
why it's better to put a character or a number for the sentinel values. But first, let's do this one because this is easier. So we are asking to the user, enter the number of students, which is n. Then this time we are checking the n value. When we reach the n value, the loop will finish. Oops, sorry. Let me close all these compilers. Enter the number of students, let's say 5. Now 5 times we will do the loop. 65, 77, 43, 21, and 19. You see? Of course, we need to change this one as well. Average will be total over n. Is that clear? Okay, I think for today it is enough. Then we will move on. We will continue from here, from the sentinel values on the next lecture. Is there any question about while loop or in general?
Yes, I have one question. I print
Yes.
my code right now.
Mm-hmm.
How can I add 0 to here?
Where? You send it to me?
Yeah.
Put the printf before the counter. Okay?
The if condition you said?
Yes. Put it before the counter.
Okay, sorry.
So it will start from 0, then increase it one by one. Okay, let me take the attendance if you don't have any other question. And by the way, I talked with the assistant, so he said to me, you will start the labs this week. I think the labs will be on Tuesday, Wednesday, and Thursday. Please check your lab groups. Your attendance is very important. And if you don't know your lab group, contact with the assistant. As I know, they
So, where is the attendance for today?
Sorry,
The attendance for today. I can't find it.
I am taking it now.
Sorry?
I am taking the attendance now. Okay, let's start. Davut Demirol. Davut Demirol, not here. Ervan Urkaya,
Yes hocam.
present. Hasan Salah,
Yes, hocam.
present. Barış Yeral,
Yes, sir.
Mustafa Melih Toslak,
Yes, hocam.
Mustafa Arkınel,
Yes, sir.
Mert Taner Salim, Ekin Ejderoğlu, Ekin Ejderoğlu, not present. Muhammed El Bushra, Muhammed El Bushran, not present. Turki Huwail.
Yes, teacher.
Asem Yahya Ali Abd.
Present.
Ammar Muhammed Abdurrahman.
Yes, sir.
Muhammed Alatas. Muhammed Alatas, not present. Didem Fatma Ateş.
Present, sir.
Ali Çetiner.
Here, sir.
Doğukan Birdal. Doğukan Birdal. Hüseyin Erenmert.
Present.
Emre Özkaya.
Here, sir.
Sultan Akcansoy.
Here, teacher.
Oyal Aktaşlı. Oyal, not here. Mustafa Hacet.
Present, sir.
Birkan Uyar.
Present.
Mustafa Bolat.
Here, teacher.
Ergül Amca.
Here, teacher.
Kürşat Alkan.
Present.
Sama Al-Obadi.
Here, sir.
Muhammed Abu Soba.
Here, sir.
Solane Ingrid.
Yes, sir.
Okay. Hamza Osman. Hamza Otman, not here. Al-Mahdi Suvan.
Here, sir.
Moet Hamayun. Moet
I'm
Hamayun.
here, sir. Moid.
Okay. Muhammed Dal Fatih El Fadul.
Present, sir.
Muhammed El Muzarihayi.
Present, sir.
Abu Bakar Sahabi.
I'm here, sir.
Zakaria El Fajuni.
Present.
Osama Baradem.
Present, sir.
Münebah El Kitani.
Present, sir.
Kate Kanucci.
Present.
Lantwadi Lamani.
Present.
Prince Mitchell. Prince Mitchell, not present. Ahmed Muhammad. Ahmed Nasar Al-Din, not present. Salem Bashat.
Yes, sir.
Yes,
I'm
sir.
here.
Which one is you? Salem?
Yes, yes.
I'm Ahmed.
Okay. Ahmed, okay. Aliyu Maikano. Aliyu, not present. Yosef El Rembali. Yosef El Sayed, not present. Sharif Al Sharif. Sharif, not present. Merve Güneyhan.
Here, hocam.
Abdullah Karis.
Present.
Raymond Stephen. Raymond Stephen, not present. Blessing Mac.
Present, sir.
Abbas Faki. Abbas Faki, not present.
Present, sir.
Okay. Obina Charles.
Present.
Hüseyin El Yasin.
Present, sir.
Ahmed Osman.
Yes, teacher.
Anas Alvarki. Anas, not present. Muhammad Kais.
Yes, sir.
Bryce Lecky.
Yes, sir.
Osama Chaplut.
Present.
Okay, now.
Sir,
Yes.
I am here.
Who are
You
you?
called my name, but I think you didn't hear me.
Who are you?
Doğukan Birdal.
Maybe your microphone was mute. Okay. Now I will take for the info students. Mihriban Özdemir.
I'm here.
Utku Yavaş. Utku Yavaş, not here. Grace Ojo.
I'm here, sir.
Okay, thank you. So see you on Wednesday. Bye bye.
See you. Bye.
Thank you.
Sir. Thank you, sir. Teacher, I'm here. You didn't say my name.
Sharif, I think I said you, but
Yeah.
okay. I am putting you.
But sorry, I have a problem with connection. Sorry.
Okay, I am putting you.
Sure.
Sharif Al Sharif, right?
Yeah, exactly.
Okay, I put you.
Teacher?
Thank
Yes.
Teacher?
you so much. Thank you so much.
Yes.
Can you give me the name of chapter 1 and 2? Because
The
I didn't.
name.
Yes. No, the name of the chapter 1 and 2.
You can find them on the Moodle. They are saved as lecture 1. Both chapter 1 and chapter 2.
Oh.
Also, you can find our book there.
Yes, okay. Thank you.
Okay, bye bye.
Bye bye.